Today we're going to talk about solving equations using our square root property. In order for this to work, you do not have to have an equation that equals 0. What you do have to have, though, is an equation where one of the factors is being squared. Okay? So when you look at your problem, if you see that you have a factor that's being squared, we can use our square root property. And the way we do that is we're going to get rid of that squared factor. And the way you get rid of something that's squared is you take the square root of it. If you take the square root of b minus 7 squared, the square and the square root cancel out, and it just leaves you with b minus 7. Now, when you take the square root on an equation, you have to actually take the square root of both sides. So I have to take the square root of 36. 36 is a perfect square, and the answer is 6 times 6. So I know that I have b minus 7 could equal 6. But what you may not know is that every perfect square actually has two sets of factors. Positive 6 times positive 6 gives me positive 36. But negative 6 times negative 6 will also give me positive 36. So it's really important when you're solving these equations and taking your square roots that you account for these two sets of factors. So the square root of 36 is actually positive 6 and negative 6. And that's how we write it in kind of a shorthand form. We put the positive and negative in front of it. Now once we've done that, this is just like a regular equation that needs to be solved. And I need to solve it twice because I know that b minus 7 might be positive 6. But I also know that b minus 7 might be negative 6. And so I rewrite it 2 times, and then I just solve each of these equations. And I find out that b might be 13, or when I add 7 to both sides here, I found out that b might be 1. So the answer is either b equals 13 or b equals 1. Now we can use this method too when we have perfect square trinomials that haven't been factored yet. Okay, so I know that this is going to be y times y, and I know that this is a perfect square 6 times 6. And if I just want to double check my middle term here to make sure this is a perfect square trinomial, it should be 2 times this first term here times this last term here. 2 times 6 times y gives me 12y. So this is going to be a perfect square trinomial, which means I can factor it using what I know with my special products. Okay, special products said this is going to be a, and then because we have an addition sign here, it's going to be plus b, which is this, squared. Okay, this is the square of a sum, so y plus 6 squared. All that equals 100. Now I have one factor that's being squared, so to solve it, I'm just going to take the square root of both sides. When I take the square root of y plus 6, I just get y plus 6. When I take the square root of y plus 6 squared, I get y plus 6. And when I take the square root of 100, remember, it's positive or negative 10. And then we just solve this twice. I know that y plus 6 could be positive 10, or y plus 6 could be negative 10. And I solve both of these equations, find out that y could be 4. So that's one of my answers. And I find out that y could also be negative 16, which is the other one of my answers. Okay? Now the only thing that makes this tricky is sometimes when you have a number that you're taking a square root of, it's a perfect square. 49 is a perfect square, so the square root is plus or minus 7. But what happens if you have a number that's not a perfect square, like 50? Well, it still needs to be simplified, so what you need to think about is how can I break 50 apart into factors that have perfect squares? There are lots of factors of 50. I could do 5 times 10, but neither of those are perfect squares. So what I want to think about is what factors of 50 have perfect squares? And I know that 25 times 2 will give me 50, and I also know that 25 is a perfect square. Once I've figured out which two factors to use, what I'm going to do is if I have a perfect square, I'm actually going to take the square root of that perfect square. So the square root of 25 is positive or negative 5. I can't take a square root of 2, so I just leave that as a square root of 2. So my answer is positive or negative 5 square roots of 2. That's how we say that answer. And now I'll show you how we can use that to help us solve these equations. Let's say I had x plus 9 squared equals 8. Since this factor is being squared, I'm going to take the square root of it, which will just leave me with x plus 9. Then I'm going to take the square root of 8. Now the square root of 8 is not a perfect square, but I know that the square root of 8 can be broken down to be the square root of 4 times 2. And I know that 4 is a perfect square. So if I take the square root of 4, I'm going to get positive or negative 2 square roots of 2. So I can use that to help me. X plus 9 equals positive or negative 2 square roots of 2. Now we still have to finish this off and find our last two answers for x. So x plus 9 could be positive 2 square roots of 2, or x plus 9 might be negative 2 square roots of 2. And you might be thinking, well, how can I solve that? Because I've got that weird number 2 square roots of 2, but it's exactly the same. You're going to isolate that variable by subtracting 9, and we get x equals negative 9 plus 2 square roots of 2, because remember, this was my positive 2. Or, when I subtract 9 over here, I'm going to be left with x equals negative 9 minus 2 square roots of 2. And this number with the square root cannot be combined, so we just leave them the way they are. This is one way to write these answers. I'm going to box these in yellow. Okay, this is one solution, or one way to write the solution to this problem. Okay, there's actually another shorthand way that you might see, so I want to talk about that really quickly. Let's go back to this problem. We had x plus 9 equals positive or negative 2 square roots of 2. Sometimes people will squish these answers together, and what they'll do is they're not going to separate this into a positive and negative. They'll just leave it the way it is. So when they subtract 9 on both sides, they get x equals negative 9 plus or minus 2 square roots of 2. And they just write it all together like that. That is also acceptable. So the way you'll see your answer is either the way the two answers that are boxed in yellow look like, or this one answer that's boxed in pink. Both of those are perfect answers.